Thank you. And remember, the water on the moon can be our water. And the astronauts will be able to do this.
What Greg brought up is, where did this stuff come from? And I think that's the question, is if indeed we find organics, and if they're a particular flavor of organics, that says, well...
Good evening, John K. McCaffrey here. NASA just announced that they found water on the moon. This is one of the most important events of the 21st century. We won't be needing this anymore. Please watch with me.
Talking about chunks of ice? Are we talking about ice within the...
That's going to come out in our studies, but based on, if I had to conjecture now, we made a nice crater, meaning we didn't hit something that was frozen. And so that says a lot about the state of the material that we hit. That will combine that information with the amount of water we derive from our spectroscopy, from our measurements, and come up with some kind of ideas of how it's distributed right now. I don't know. I think it's safe to say it wasn't a frozen lake. All the water wasn't on a perfect surface at the top, on a frozen film, but it was probably intermixed within the grains, frozen granules and whatnot. That remains to be seen, though. I mean, that's some of the ongoing work we need to do, really taking all the data sets and combining them into one story.
If a person were to stand there, what would it look like? Would it look different?
I don't know. That's a good question. We've been talking about that, and based on some of the observations, it would be an interesting place to walk around, I think. Some of these species that we're talking about are fairly volatile, other than water. We hit a very cold place, minus 220 degrees below 0 centigrade, but some of the species that we think we may be seeing are fairly volatile. So, meaning you don't have to warm them up much, just by 20 or 30 degrees, and they're going to bubble off. We do have, what's fantastic is we have these near-infrared camera images of the Floricobaeus. So we actually can relate those to what the human eye would potentially see. And so that is in our plans, is we have these images that we never really anticipated having. We're going to go look at those very closely, understand the reflectance, and understand exactly what the terrain looks like. That is important, actually, to understanding what it is we hit.
Are you saying you saw water before impact?
No, we're not saying we never saw the floor of the crater before impact. We only saw it once we got way down low after the impact. But the brightness of the terrain where we hit, we can actually understand that and say something about what the floor looks like.
Okay. Thank you, Wayne. Do you have any other questions in the audience? Okay, we have one up front here. We have one up front.
Yeah, I guess if you can talk about the thermal characteristics of the impact and water versus ice and the 12 buckets and how much got evaporated or went into vapor and that sort of thing, and anything about the characteristics after the impact of the cloud. Did it all go off, or did some of it come back? Or
Sure. Yeah, it was as one of our co-investigators put it, it was a tepid impact, meaning cold in his experience, meaning it was probably about 1,000 degrees Kelvin, or about 700 or so degrees Celsius. And that's cold for impacts. But that's kind of what might be expected with a low-density rocket, impacting fairly slowly. There is evidence for a vapor and debris cloud that came up at a very sharp angle, very early or immediately after impact, that rose very quickly and got to altitudes above the crater rim within seconds after impact. And At the same time, a lower angle, more traditional ejector curtain came up laterally outwards, and that's what we see actually in the image is a lower density plume coming straight up at us, and then a higher density plume coming out to the sides. All of that returned back to the moon. And there's evidence for actually that falling down in the area around the crater of several hundred meters to a kilometer out around our impact site. There's actually indications of that. In our thermal imaging, what was great is our thermal cameras could measure the impact plume temperature all the way down, and then we can measure the temperature of the crater, and that's where we're getting some of the estimates. At the 4 minutes after the impact, the crater temperature and some of the debris blanket around the crater was still minus 40 degrees, minus 50 degrees centigrade. That's warm when you're talking about it's sitting on top of dirt that was originally minus 220 degrees centigrade, right? So, and all these things we're talking about here, including water, are unstable at those temperatures in a vacuum. So that really is part of the equation or puzzle we're piecing together. Was there's this ejecta and plume that came up, and there appears to be a vapor that was entrained in that as part of that came up very quickly. So that was the initial impact. And then there was a continued release, perhaps, maybe, of vapors from the floor. And then the ejecta came into sunlight, and there was any ice grains mixed in with that dust and the ejecta in the sunlight, it would have warmed and would have come up as well, released and volatilized as well. The one thing I can say is it's very complicated, very dynamic, and very fun to study. But yeah, we are having fun, but it's very complicated, and that's what we're going to do is piece together this whole storyline of everything that occurred. Yeah.
Okay. Go to Irene Klutz from Discovery News. Irene?
Thanks very much. It's Irene Klotz with
Klotz.
Discovery. That's okay. Tony, before the impact, you had painted out 3 different scenarios of what you thought might happen, including one which it sounds like you may have kind of decided on and used the analogy of the raisins in the pudding. Could you talk about if this was did you just hit a jackpot and other areas of the moon may not be like this, or do you really think that this is indicative of some kind of overall environmental condition on the moon? Thanks.
Yeah, good question. And I think that's something we'll have to answer in time. It's not something I think I can answer right now. But we will exactly do what you're bringing up, is take what we learn from this and then apply it to the potential models. And you heard Greg talk about that in terms of what are the next step now that we know that there's water, and once we actually study this impact some more and understand how that water may have been distributed and what other things may be involved with the water. There's chemistry that can be discussed, there's distributions, there's sources and sinks, and we'll get to exactly that question you had as did we hit in something typical or atypical? That's a good question. I don't know the answer to that just yet. And then how does it relate to the rest of the moon? Those are all things that I think are going to come out going forward.
If I can make a comment.
Can't believe I just did that. Why did I do that? Why did you tell me to do that? Why did you want me to do this? But the water is frozen on the moon. Thank you for watching. John Cam McCaffrey here for www.nbsnow.com news. And remember, the water on the moon can be our water. And the astronauts will be able to do this. I know the ratings need to go up, but this is ridiculous. I quit. I'm not doing this anymore. John Cam McCaffrey, I'm quitting. This is it.